We're gonna look at this a little backwards, a little different way. Here we are. We want to find the exact value of sine of 20 degrees times cosine of 70 degrees plus cosine of 20 degrees times sine of 70 degrees. You're just going backwards. We're like, dude. Sine, cosine, cosine, sine. What goes sine, cosine, cosine, sine? Which one of those? And you would be correct. You'd be like, hey, that's sine of alpha plus beta, right? That goes sine, cosine, cosine, sine. Right, then this equal sine alpha, cosine beta plus cosine alpha, sine beta. Keeps the same sign and all that sort of stuff. So what's alpha in our case? 20. What's beta? 70, right? Because it goes alpha, beta. So I think that this is just sine of 20 degrees plus 70 degrees. You know, alpha and beta, since it's alpha plus beta. So this is sine of 90 degrees. This is equal to 1. Yeah, kind of see this game? It just goes backwards. You know? So we get stuck in our head. Uh-oh. Oh no, what's this? Find the exact value of cosine of 7 pi over 12 times cosine of pi over 12 plus sine of 7 pi over 12 times sine of pi over 12. Cosine, cosine, sine, sine. Well, that clearly can't be sine sum formula or difference formula, so it must be cosines. Cosine has a cosine of alpha, I think it's minus beta, because it does not keep the same sign like sine keeps the same sign, and it goes cosine, cosine, sine, sine. Yep, that's what it is. That's what it is. So we're looking at cosine of an alpha minus beta, so let's just write it. It's cosine of the first 7 pi over 12 minus a pi over 12. Well, shoot, that's cosine of 6 pi's over 12, but you wouldn't leave an even number over an even number. You'd be like, bruh, that's pi over 2, and cosine of any odd multiple of pi over 2 is always equal to 0, and that's that. Can you add fractions? You're going to be freaked out about those pi's over 12s and stuff like that? You're going to have to add in subtracting. That's going to be the tricks I use for your exam. All right, on to the next. Let's just keep playing. We're going to play the same game. We're going to do it just a little bit different. We're going to write an expression as the sine or cosine of an angle. So one thing is what it's trying to say. We got two different angles. We got 9x and we got 3x. We need just one angle. What goes sine, cosine, cosine, sine? Oh yeah, buddy. Sine, cosine, cosine, sine. That's sine of alpha minus beta. Where our alpha is going to be that 9x, our beta is going to be that 3x. 9x minus 3x? Shit. That's sine of 9x. Or 6x, sorry, I misspoke. Write an expression as the sine or cosine of an angle. There's just one angle. There it is. So just a couple of the quick games helps you go through your homework. Sum and difference formulas, they're cool. You should get them locked in, pass your test, and be able to play around with them. As we move forward, they're really just kind of a building block that creates everything else. So in our next, we'll step it up.